Welcome back to physics class. Today we are going to study about nuclear reactor. What is a nuclear reactor? It's a system designed to control the fission chain reaction. We had already studied what is a nuclear fission reaction, what is a nuclear chain reaction. Now, nuclear reactor is a system which is designed to control a fission chain reaction, or we can say that it's an efficient source of energy. In each nuclear fission, more energy, approximately 200 MeV energy is released. So we can have an efficient source of energy, or we can have a large amount of energy from a nuclear reactor. And we had already discussed about K, that is a reproduction constant. Reproduction constant K is defined as the average number of neutrons available from each fission that will cause another fission for a controlled self-sustained chain reaction. And we know that for a steady chain reaction, K must be equal to 1. Once again, K is defined as the average number of neutrons available from each fission that will cause another fission for a controlled or self-sustained chain reaction. In this class, we are going to find out the different parts of a nuclear reactor which you had studied in your plus 2 classes. So this is an overview of a nuclear reactor. On the left hand side, you can see control rods and a reactor core, and from that hot water is passed through a chamber, and in which it gets mixed up with the cool water, so that steam is produced, and that steam is given to a turbine or an electric generator for producing electricity. In the lower part, you can see the cool water coming from river or lake or ocean, which act as a coolant to remove the heat. And the whole main apparatus is shielded in a confinement shell. So this is an overview of a nuclear reactor. We will move on to the different parts or the important points of a nuclear reactor. The first main part is fuel. Fuel is a fissionable material. That is the material that undergoes the process of fission. And the commonly used fissionable materials are uranium-238, enriched with uranium-238, and also plutonium Pu-239. So these are the commonly used fissionable materials which we use in a nuclear reactor as fuel. The last class we had studied about moderator, isn't it? The neutrons released in a nuclear fission, have high kinetic energy. So they are fast moving neutrons, but such neutrons cannot trigger the fission of uranium-235 and have a high chance of being captured by uranium-238. So to slow down this fast moving neutrons, we are using moderators. And as moderators, we are using heavy water or graphite or beryllium oxide. Now, how we can take a good moderator? We know that we are going to slow down the neutrons with the help of moderator. So moderator must have a mass comparable with that of neutrons. Moderator should have a mass comparable with that of neutrons. Now, moderator, what is the function of moderator? Moderator has to slow down the neutrons, isn't it? And it should not capture or it should not absorb the neutrons. So, the second condition is that, or second necessity is that moderator should have a low capture of neutrons. So, we use the moderator in order to slow down the fast moving neutrons released in a nuclear fission process, and the moderator must have a mass comparable with the neutrons and it should have a low capture of neutrons. Third one, coolant. We know that in each fission process large amount of energy is released, and the energy released is mainly in the form of heat. So as the name denotes, coolants will help to remove the heat, and this is done with the help of air, water or carbon dioxide. So these are used as coolants to remove the heat from the core region of a nuclear reactor, and this removed heat is used for producing steam, so that this steam can drive the turbines in order to produce electricity. Now, control rods. Control rods are used to control the rate of fission. So they are given the name control rods. They are 2 or 3 rods which helps you to control the rate of fission and also helps to shut down the reactor in case of any emergency. So how will the control rod will perform in a nuclear reactor? It will absorb the neutrons so that the fission process can be slowed down, or by absorbing more amount of neutrons the fission process can be stopped. So as control rods, cadmium rods are used, and they are good absorber of neutrons. And last portion is a shield. Shield, you know, it is used to avoid the various radiations coming out from the reactor, and it is surrounded by a radiation shield which is in the form of a thick concrete wall. So that's about the different parts of a nuclear reactor. Now moving on to the uses. Nuclear reactors are used to produce radioactive isotopes which are used in medicine, industry and agriculture. Then we had already said that the steam is used for generating electricity, so it is used in electric power generation. Also used for the propulsion of ships, submarines and aircrafts, and it's also used as a source of fast neutrons. So the fast neutrons which is available from a nuclear reactor can be used in several other reactions also. So these are the uses of a nuclear reactor. And we know that this nuclear reactor is a very efficient source of energy. Now the next is breeder reactor. Reactors that can produce more fissile fuel than it consumes are called breeder reactor. Once again, reactors that can produce more fissile fuel than it consumes are called breeder reactor. So it's an alternate to thermal reactors in which fission is produced by slow neutrons or thermal neutrons. And we know that in nuclear fission, uranium nucleus is bombarded with slow neutrons. And that slow moving or low energy neutrons are called thermal neutrons. But in breeder reactor, we use fast neutrons. So fast neutrons are used in breeder reactors. Why we are using breeder reactors? We had already nuclear fission reactions and nuclear reactors. Then why we are using breeder reactors? Because the fission of uranium-235 are uneconomical. That is, there is less natural abundance of uranium-235. So we cannot use uranium, we are not able to obtain uranium-235 more. So what we are doing is that we are transforming non-fissionable nucleus into fissionable one. So we are converting non-fissionable nuclide into fissionable ones. For example, uranium-238. Uranium-238 is a non-fissionable nucleus. Now, when this uranium-238 captures a fast neutron, it becomes uranium-239. Now this uranium-239 is in excited state, isn't it? So what happens? It undergo decay process. It undergo decay by emission, beta emission process with a half-life of 23.5 minutes. And this uranium will become a neptunium, that is Np239, which in turn again undergo beta emission or beta decay and forms plutonium-239. And this plutonium isotope is fissionable and can be used as a fuel, reactor fuel. So what's the reason for using breeder reactor? Since there is less natural abundance of uranium-235, we are transforming a non-fissionable uranium-238 into fissionable plutonium in breeder reactors. So breeder reactors are the reactors that can produce more fissile fuel than it consumes. So let's have a look on what we had said. A neutron, which is a fast neutron, bombarded with the uranium-92-238, which is non-fissionable, and it undergo beta decay. Now on capturing the fast neutron, it becomes uranium-92-239, isn't it? Now that undergo beta decay and forms neptunium. Again this neptunium undergo beta decay. Beta decay means emission of an electron. And it undergo beta decay and forms plutonium-94-239, which is a fissionable fuel. So there are different reactions, breeder reactions are there. So this is a reaction involving uranium. Now there is also another reaction regarding thorium. When thorium-232 on bombarding with the fast neutron, it becomes thorium-233 and undergo gamma decay followed by beta decay and forms uranium-233. So that's another example for breeder reaction, that is converting thorium-232 into uranium-233. So that's about the breeder reaction. So we had discussed what is a nuclear reactor and what is a breeder reactor. Thank you.